Start by understanding what the ozone layer actually is. The ozone layer is a thin region of Earth's stratosphere, about 15 to 35 kilometers above the surface, containing a high concentration of ozone molecules. This layer acts as a protective shield, absorbing most of the sun's harmful ultraviolet radiation. Without it, life on Earth would be exposed to dangerous levels of UV rays, which can cause skin cancer, cataracts, and harm to plants and animals. The ozone layer is essential for maintaining the balance of ecosystems and protecting all living things. Now, let's explore how this vital shield is being threatened. Depletion of the ozone layer was first noticed in the 1970s, when scientists observed a significant thinning over Antarctica. This alarming discovery led to further research, revealing that certain human-made chemicals were responsible for breaking down ozone molecules. The most famous of these discoveries was the so-called ozone hole, a dramatic seasonal reduction in ozone concentration. This finding shocked the world and prompted urgent scientific and political attention. Understanding how and why this depletion occurs is crucial for developing solutions to protect our planet. Ozone depletion is primarily caused by human-made chemicals known as chlorofluorocarbons or CFCs. These compounds were widely used in refrigeration, air conditioning, foam production, and aerosol sprays. When CFCs are released into the atmosphere, they eventually rise to the stratosphere, where ultraviolet radiation breaks them down, releasing chlorine atoms. These chlorine atoms react with ozone molecules, destroying them in the process. Other chemicals, such as halons and certain solvents, also contribute to ozone depletion. Let's look closer at how these reactions happen. CFCs reach the stratosphere, they are broken apart by ultraviolet light, releasing chlorine atoms. A single chlorine atom can destroy thousands of ozone molecules before it is removed from the atmosphere. This chain reaction is highly efficient and devastating for the ozone layer. The process is especially intense over Antarctica, where unique weather conditions create clouds that enhance the breakdown of ozone. Understanding this destructive process helps us see why reducing CFC emissions is so important. Most dramatic evidence of ozone depletion is the annual ozone hole that forms over Antarctica. Each spring, the combination of cold temperatures and sunlight triggers chemical reactions that rapidly destroy ozone. This leads to a significant thinning of the ozone layer, sometimes by more than 60%. The ozone hole has become a symbol of environmental damage and a wake-up call for global action. Scientists monitor its size and severity every year to track progress and guide policy decisions. The ozone layer is crucial because it absorbs most of the sun's harmful ultraviolet UVB radiation. Without this protection, humans would face higher risks of skin cancer, cataracts, and weakened immune systems. Plants and animals would also suffer, with crops yielding less and aquatic life being threatened. The ozone layer's role in shielding life on Earth cannot be overstated. Its depletion puts the health of ecosystems and people at serious risk. Ozone depletion leads to increased levels of ultraviolet radiation reaching the Earth's surface. This can cause a range of health problems in humans, including higher rates of skin cancer and cataracts. UV radiation can also suppress the immune system, making people more vulnerable to infections. These health risks highlight the importance of protecting the ozone layer and reducing our exposure to harmful chemicals. Effects of ozone depletion are not limited to humans. Plants can suffer from reduced growth, lower crop yields, and damage to leaves. Animals, especially those living in or near water, are also at risk. Increased UV radiation can harm phytoplankton, the foundation of aquatic food chains, and disrupt entire ecosystems. Protecting the ozone layer is essential for maintaining biodiversity and food security. Ozone depletion and climate change are closely linked. Some ozone-depleting substances are also powerful greenhouse gases, contributing to global warming. Changes in the ozone layer can affect atmospheric circulation and weather patterns. Addressing ozone depletion helps not only to protect life from UV radiation, but also to mitigate climate change. This connection underscores the importance of coordinated global action. In response to the growing threat of ozone depletion, the international community adopted the Montreal Protocol in 1987. This landmark agreement aimed to phase out the production and use of ozone-depleting substances, including CFCs and halons. The Montreal Protocol is considered one of the most successful environmental treaties, with nearly every country in the world participating. Its implementation has led to significant reductions in harmful emissions and a gradual recovery of the ozone layer. Montreal Protocol works by setting binding targets for countries to reduce and eventually eliminate the use of ozone-depleting substances. It provides a framework for monitoring, reporting, and verifying compliance. The protocol also supports developing countries with financial and technical assistance, helping them transition to safer alternatives. This collaborative approach has been key to its success and has inspired similar efforts in other areas of environmental protection. One of the major achievements of the Montreal Protocol has been the development and adoption of alternatives to CFCs. These include hydrofluorocarbons HFCs, which do not harm the ozone layer, and other environmentally friendly substances. While some alternatives have their own environmental impacts, ongoing research aims to find solutions that are both effective and sustainable. The transition to safer chemicals is an ongoing process, requiring innovation and commitment from industry and governments. Thanks to global efforts, there has been significant progress in the recovery of the ozone layer. Satellite data and ground-based measurements show that ozone concentrations are slowly increasing, especially over Antarctica. While full recovery will take several decades, the positive trends are encouraging. Continued vigilance and adherence to international agreements are essential to ensure that the ozone layer continues to heal. Despite progress, challenges remain. Illegal production and use of banned substances continue in some regions. New chemicals with ozone-depleting potential are still being discovered. Monitoring and enforcement are critical to prevent setbacks. The fight to protect the ozone layer requires constant vigilance, international cooperation, and public awareness. Let's look at what individuals and communities can do to help. Individuals can contribute to ozone protection by choosing products that are labeled as ozone-friendly and avoiding those that contain banned substances. Proper disposal of old refrigerators and air conditioners is important, as they may contain CFCs. Supporting policies and organizations that promote environmental protection also makes a difference. Every small action counts in the global effort to safeguard the ozone layer. Industries play a crucial role in protecting the ozone layer. By adopting cleaner technologies and phasing out harmful chemicals, companies can reduce their environmental impact. Many businesses have already made significant changes, investing in research and development to find safer alternatives. Collaboration between industry, government, and scientists is essential for continued progress. Governments have a responsibility to enforce regulations, monitor compliance, and support research into new solutions. Effective policies, public education campaigns, and international cooperation are all vital. By working together, governments can ensure that the gains made in ozone protection are not lost and that future generations inherit a healthier planet. Continuous scientific monitoring is essential for tracking the health of the ozone layer. Satellites, ground stations, and balloons are used to measure ozone concentrations and detect changes. This data helps scientists understand trends, identify new threats, and inform policy decisions. Ongoing research is key to ensuring that the ozone layer continues to recover. Raising public awareness about ozone depletion is vital. Educational programs in schools, media campaigns, and community events can help people understand the importance of the ozone layer and how to protect it. When more people are informed, they are more likely to make choices that benefit the environment and support protective policies. Technological innovation has played a major role in reducing ozone depletion. New refrigeration and air conditioning systems use chemicals that do not harm the ozone layer. Advances in manufacturing and product design have also contributed to safer alternatives. Continued investment in research and development is necessary to ensure that technology remains a force for environmental protection. Protecting the ozone layer is a global challenge that requires international cooperation. The success of the Montreal Protocol demonstrates what can be achieved when countries work together. Sharing knowledge, resources, and technology helps ensure that all nations can participate in ozone protection efforts. Continued collaboration is essential for long-term success. Experts estimate that, if current policies are maintained, the ozone layer could return to pre-1980 levels by the middle of this century. Recovery is a slow process because ozone-depleting substances remain in the atmosphere for many years. Continued adherence to international agreements and vigilance against new threats are necessary to achieve full recovery. Despite progress, there have been unexpected setbacks in ozone recovery. For example, illegal emissions of CFC-11 were detected in recent years, slowing the healing process. Rapid detection and response are crucial to address such issues. This highlights the importance of robust monitoring and enforcement mechanisms. Ozone is a molecule made up of 3 oxygen atoms. It is formed and destroyed naturally in the stratosphere through complex chemical reactions involving sunlight. Human-made chemicals disrupt this balance, leading to net ozone loss. Understanding the science behind these reactions is key to developing effective solutions. It's important to note that ozone levels fluctuate naturally due to factors like solar activity, volcanic eruptions, and weather patterns. However, the rapid and severe depletion observed in recent decades is primarily due to human activities. Distinguishing between natural and human-caused changes helps scientists accurately assess the problem. Ozone-depleting substances include CFCs, halons, carbon tetrachloride, and methyl chloroform. Each of these chemicals has different uses and ozone-destroying potential. International agreements target these substances for phase-out with strict controls on their production and use. Ozone concentration is measured using satellites, ground-based instruments, and weather balloons. These tools provide detailed data on ozone levels around the world. Accurate measurement is essential for tracking trends, identifying problems, and evaluating the effectiveness of policies. Many everyday activities contribute to ozone depletion, often without people realizing it. Using certain air conditioners, refrigerators, and aerosol sprays can release harmful chemicals. Being aware of these sources helps individuals make better choices and reduce their environmental impact. Effective policies are essential for protecting the ozone layer. Regulations on the production, use, and disposal of ozone-depleting substances have made a significant difference. Ongoing policy development and enforcement are needed to address new challenges and ensure lasting protection. Protecting the ozone layer is an ongoing responsibility. Even as the situation improves, new threats can emerge. Vigilance in monitoring, enforcement, and public education ensures that progress is maintained and setbacks are quickly addressed. The UV index is a measure of the strength of ultraviolet radiation reaching the Earth's surface. When the ozone layer is depleted, the UV index rises, increasing health risks. Monitoring the UV index helps people take precautions such as wearing sunscreen and protective clothing. Wildlife is particularly vulnerable to increased UV radiation. Amphibians, fish, and other aquatic species can experience developmental problems and population declines. Protecting the ozone layer is essential for preserving biodiversity and healthy ecosystems. Agriculture relies on healthy plants which are sensitive to UV radiation. Ozone depletion can reduce crop yields and damage food supplies. Farmers may need to adapt by using protective coverings or developing UV-resistant crops. Ensuring a stable ozone layer supports global food security. Oceans are affected by ozone depletion because increased UV radiation can harm phytoplankton, the base of marine food webs. This can disrupt entire ocean ecosystems and impact fisheries. Protecting the ozone layer is vital for the health of our oceans and the livelihoods of millions of people. Forests play a key role in absorbing carbon dioxide and supporting biodiversity. Ozone depletion can weaken trees, reduce growth, and make forests more vulnerable to disease and pests. Healthy forests depend on a stable ozone layer to thrive. A healthy ozone layer supports human development by protecting health, agriculture, and natural resources. Its depletion threatens progress in these areas, especially in developing countries. Ensuring ozone protection is part of building a sustainable future for all. Technology has both contributed to and helped solve the problem of ozone depletion. While some inventions released harmful chemicals, others have provided safer alternatives. Continued innovation is essential for balancing progress with environmental protection. Protecting the ozone layer is not just about today, it's about ensuring a safe and healthy environment for future generations. The actions we take now will determine the quality of life for our children and grandchildren. Long-term thinking and commitment are essential. The health of the ozone layer is directly linked to global health. Increased UV radiation can lead to more cases of skin cancer, eye diseases, and other health problems worldwide. Protecting the ozone layer is a public health priority. The Montreal Protocol is often cited as a model for successful international environmental policy. Its achievements show that global cooperation and science-based decision-making can solve even the most complex problems. The lessons learned can be applied to other environmental challenges. Innovation has been a driving force in the fight against ozone depletion. From new chemicals to advanced monitoring systems, creative solutions have made a real difference. Encouraging innovation ensures that we continue to find better ways to protect the environment. Everyone has a role to play in protecting the ozone layer. By making informed choices, supporting environmental policies, and spreading awareness, individuals can contribute to a healthier planet. Personal responsibility is the foundation of collective action. Looking ahead, the future of the ozone layer depends on our continued commitment to protection and innovation. By learning from the past and staying vigilant, we can ensure that the ozone layer remains a shield for generations to come. The story of ozone depletion is a reminder of the power of science, policy, and collective action. To sum up, the ozone layer is a vital shield that protects life on Earth from harmful UV radiation. Human activities have caused significant depletion, but global action has made a difference. Continued vigilance, innovation, and cooperation are essential for full recovery and long-term protection. The story of ozone depletion is both a warning and a source of hope. It shows that when people, governments, and industries work together, real change is possible. Let's continue to protect the ozone layer and ensure a healthier, safer world for all.